right, shall we get started? Just first, can I get a thumbs up? Can people actually see me? I'm having some connection issues, so. I do not see very many thumbs up.
You're good.
Cool, okay, good. So we're gonna get started in just a couple minutes. First, I'm actually wondering what you guys really want to review. Some of you seeing some lag. I might turn off my video. Is my audio okay?
Your audio has been fine. Yeah.
Oh, rip Zoom. Cool. Okay, so I'm gonna turn off my video. Hopefully that helps things. But if you guys want to review stuff in particular, please put it in the chat. We have some stuff that we've just prepared, but I can also just answer some random questions. So if you tell me stuff, I'll try to cover it. Yeah, we'll be covering some API stuff, and at the end you can, or when we get there, you can tell me if you want more details. And yes, we'll cover what Express, what you need to know about Express to for the purposes of this class at least. All right, I think it's about time we get started, so I'm going to go ahead. So welcome back everyone to another week of Web Lab. Hopefully you guys got some rest over the weekend, got some good feedback on your project ideas. So we're going to jump in with a recap of all the things we did last week before we kick off with this week. So last week we didn't cover all that much. All we did was cover 3 new languages, an entire front-end library, how to use APIs, what servers are and how to make them, how to use databases. Yeah, we hardly covered anything at all. No, we really did cover a lot, and it makes sense if any of you are confused about something or need to review, and that's what this is for. I'd also like to take this moment to point out that we have a lot of time at office hours to help anyone who wants. So far, not that many people have been going, which is a real shame because we have a lot of staff there, and we like answering questions. So please come to office hours if you're at all confused about anything. So jumping right into the recap, we first started off with the 3 languages that we use when coding in a browser. We use HTML to organize the page and to introduce all the context, all the text and images that we're going to put on the website. On top of that, we have CSS, which is responsible for styling it so that we can, so that way it looks how we want it to. In addition, we have JavaScript, which is used for typing some text. And it also helps with getting data, and which is a great segue because how do you get data on the internet? You use HTTP. HTTP is just a way to communicate on the internet. We don't really need to know more details for the purposes of this class. You guys have seen HTTP a lot in the context of GET requests and POST requests. These 2 requests, we built some functions to help you. That's just GET and POST from utilities.js. And really all it is asking for information or asking to write new information. I see someone in the chat asking for real-time updating. We're actually covering that on Tuesday and Wednesday. It's the socket lectures. So communications, these GET and POST requests are usually used to interact with APIs. Well, some of you might still be wondering, what really is an API? An API is just a function call over the internet. It's just a function call. The function has some name like /pet/ID. Here. So this would be the function's name of the API. And we're calling /pet/pet ID. And when we do that, we provide the pet ID as a parameter, and we say, give me the pet with this particular ID. Does that make sense so far? And can people still see? I'm seeing some lag, so please give me some thumbs up if you are seeing and hearing me okay. Excellent. All right. Is everyone's okay with this so far? Makes sense? An API is literally, it's just a function call. We have some parameters, oops. We have some parameters which we might pass. We have a return type, which may be confusing because it's not explicitly defined. There's nowhere where we say we're going to return an object with ID, category, and name as the fields. But if we document our code correctly, then it'll make a lot more sense to us, and we can know what the return type is. So APIs are just function calls. When we call these API requests or these HTTP requests, they take a really long time, which is why JavaScript is an asynchronous programming language. When we make one of these calls, we don't want to wait until it finishes, which could take a second if the signal is going all the way around the world. And so we don't want to wait for that to happen, because otherwise maybe the user can't click a button or can't type anything. So what JavaScript does is it simply sends out the request and continues on executing the code. So in the case of this example on screen here, can anyone say what they think this console.log will print out, just as a review? Just type in chat. I'm seeing some unknowns and I'm seeing some IDKs. Well, if IDK is code for unknown, then you are correct. The answer is unknown because when we do this GET request for /pet/0, what's happening is we're sending out a request somewhere on the internet. We're saying, please get me the pet whose ID is 0. And we're saying that this is going to be a Labrador. But this request is going to take some time. So we call this GET request, and then the function that we pass to .then doesn't get executed until that request completes. Diego, technically that's true. We don't know. We assume that this GET request is going to take more than a millisecond to come back. And in that time, this console.log at the bottom will already have run. And so we can relatively safely assume that this console.log will print out unknown. Someone in chat, we don't really know how fast it will complete, and you can't really rely on that. I think it's just safe to assume that it takes longer to send a request on the internet than it does to print out one word. I think it's not something you'd probably do in like an algorithms class because it wouldn't be safe. So is everyone okay on this asynchronous programming? I think that's a really big deal. So if you can give a thumbs up if you're feeling okay on that. Okay, seeing a little bit more tentative thumbs up, but I think that's okay. The main point is when you do a function call that returns a promise, you're going to be waiting for that code to finish before you do the .then. So Vedanta asked, how do you get the async to connect back to the original program? The way you do that is, actually, you kind of don't. This function just runs and it stops. So this arrow function that says pet name equals pet.name, it doesn't connect back into the rest of the program. When the browser notices that you're not really doing anything in the main code, it'll say, hey, can I run this function yet? Because the request is completed. If the request is completed, then it says, then it runs it, and once it finishes running it, it's done. It never connects back. I think it's about time I move on from that to more things about promises. So when you make a GET request like this, maybe you have some input you're calling an API request that says add one. You'd never have a real API request like this, but just for example, when you call this, you expect to give you back 6. I think that makes sense. Just an object type that has 2 really useful functions, .then and .catch. .then is used like this. So we say, we pass in an error function and we say, when the response comes back, then we're going to want to call this function. In this case, this function is going to call add one again. It's going to use the API again. And this promise is smart enough to know that when we return, when this inner get request returns a promise, we're going to this .then says we're just going to add one. So in this case, we're not returning a promise, we're just returning a value. And so that value, so we see if we add 1 to 5, we get 6 as the response. If we add 1 to 6, then we get 7. And finally, we print out 7. And then really at the end of every string of promises, you want to have a .catch. This is really important, especially with newer JavaScript, because I think they're deprecating having errors that aren't caught, which basically means that if you ever don't catch an error, then your code might just completely crash. So especially on the server, it's really important to catch this kind of error. How's everybody feeling on that? This one is really important. So if I could get some more thumbs ups, I'll stop asking for this quite so often. Okay, there's again a little bit more tentative. Request to redefine a promise. Yeah, so a promise is just a placeholder for some data that we haven't gotten yet. What it really means is we're saying, hey, give me 1 more than 5, and I'll wait for your answer. So we return a promise, and the promise starts out saying, I'm not done yet. If we try to just print the get request, it would say, I'm not done yet. But if we say .then and we give it a function, what that's doing is it says what that function is saying is what we run when we finally do have an answer to that promise. And the reason we do it this way is because otherwise we'd have to just sit in the for loop saying, is the promise done yet? Is the promise done yet? Is the promise done yet? And that's really annoying to do. So instead we use this .then syntax in order to avoid that kind of annoyance. I think I actually was slightly inconsistent in the way I used response.output, so ignore that part. Don't think too much into it. I was trying to make it a more interesting API call, and I don't think I updated it properly. One really important thing is that you can chain these .thens as many times as you want. You can have as many .thens in a row as you want. It just makes sure that you call all these functions in a row. So when the previous .then completes, the next .then goes. All right, I think we're just about out of time for this, so I'm going to keep moving on. So going into React. React code is it's a really useful library that allows you to combine your HTML and JavaScript into really reusable components, well, called components. So we have an overarching component called app that runs our entire web application. And this app contains some pages like feed and profile, as well as a reusable component called navbar, which appears in both feed and profile. We also get the smaller components like card and new post, which get used multiple times inside a feed. So the really important thing here is that we can reuse these components even multiple times at the same time without having any difficulties. So when you're writing a React component, we come down to 3 methods inside of a class. So you have class example, which means our component is called example, extends component, and we get the constructor, component did mount, and render, as well as this export statement at the bottom. We'll just always have that. So To briefly go into what these functions mean, the constructor simply creates the component. So in the constructor, you'll always have this super props line, which will basically tell React that this really is a component. We really want it to run React things. And when this constructor runs is when we create an example. It's just like init in Python. When we construct this example component, then we run the constructor. In this case, when we pass in some props into the example, those props show up as fields of this props object, which will eventually be accessible as this.props. After that, we have the component did mount function. This function gets called when we need to get data from the server, or it gets called after the first render. And that's where we should put any calls for data from the server. Unfortunately, we can't put those calls inside of constructor because React might crash. You should never have any calls that might result in a set state before component did mount runs. So that's why we put all the get requests in here. This code only runs after the first render. It's never run again. So it's only in the setup phase. So you make all your API requests here. Finally, we have the render function. This is the last of the methods that you really need to know by heart. This render function defines how your component looks on the screen. So it just returns a bunch of HTML. And you can mix some HTML and JavaScript, so you can reorganize your HTML code here, however it makes it look better, and insert whatever data you want to insert. When you're writing code here, remember that HTML code should be wrapped in parentheses. Sometimes you can get away without the parentheses, but it makes it a lot clearer if you just put them in. Inside of that HTML code, you can put JavaScript code by wrapping it in curly braces. That will bring you back into JavaScript. So before we move on from React, does anybody have any questions or feel good about this? Thumbs up. Seeing one person, okay. All right, yeah, looks good. People are feeling good about React. Love to hear it. So moving on to servers. So if you remember, a server is just some computer sitting out on the internet. It's sitting in some other building. It's not a magical thing in a magical cloud. It's just a computer running your server code and running it in a loop, waiting for you to connect and make an HTTP request. So maybe you say get/API/puppy pictures. And the server computes for a little while and then sends you back a puppy picture as a response to that request. And that's pretty much all a server is. It's just a machine sitting there waiting for a request. But the nice thing about it is that the server can handle many clients at a time. It doesn't just wait for your request. It waits for a bunch of people. And this can be really useful because it allows us to access some files or whatever data we have stored. It allows us to have a source of truth so that, like, if we're playing a game, maybe it tells us if somebody's lying, or it tells us if who went first. It also allows us to have some security so that we can log people in, as you'll actually see today, and you can avoid people accessing things they shouldn't access. When you're writing your server code, you'll probably be writing in node.js and using Express. And we've thrown these words around a lot, and it's kind of confusing to know what they mean. Honestly, I'm not really sure what they mean because it doesn't matter. It's just JavaScript code that's running your server. That's all you really need to know. And like all of the stuff that sets up the server for you is in server.js, and it's mostly done for you. We've written it all together in this class when we were setting up the server on Friday. And honestly, you can just reuse that part. There's not many changes you ever need to make to it. I think you can build a fully functional website without making a single change to it. Most of your changes are going to be in api.js. And what you're going to be doing is you're going to be building routes. You're going to use this syntax. So router.get to define a GET request and router.post to define a POST request. And again, these when you're defining these are just functions. You're saying the function name visible / API here because of what we did in server.js. And then ideally, these requests would also come with some documentation saying, oh, the exact parameters for this GET request, there's no parameters, but it returns a list of stories. And for this POST request, the parameter is the rec.body.content, which defines the content of the new story. So this hopefully is all familiar to you guys, but I just want to show that there's not really any magic going on here. It's just some, it's just this simple defining route. And that's really all that that's most of what the work will come down to for these websites. So when you're connecting to a server, let's say you just type this in your URL bar, you provide the protocol and you provide a domain name like facebook.com. But what you probably aren't used to typing out is a port number. So this port number is useful because it tells you which server you're going to bind to, which server you're going to connect to, because there can actually be more than one server on a computer. So in this case, there's a server running at port 8000 and a server running at port 3000. You guys should actually be familiar with this because when you're running your hot loader and your server at the same time, you have one thing running at port localhost 5000 and one at localhost 3000. So in general, it's just protocol, then domain, and then port. Normally, we don't actually need to specify this because these ports are default. So when you just type in a URL, it knows which port to go to. When you're using your own computer as a server, though, you realize every computer can run server code. It's just your computer just becomes one of the many computers on the internet. And again, you use localhost as the name, and you can create ports like localhost 3000 for your server or 5000 for your hot loader. And up next, we have databases, where when we're running our server code, we need a good place to store all of our data. We need it somewhere we can trust, and we really don't want to worry about the security or making sure that our data doesn't get corrupted or something. So we just tell MongoDB to do that for us. And that's really what everyone does because no one wants to figure out how to do that when it's already been solved. When you're writing code for MongoDB, you're going to be defining schemas and models. And once again, there's nothing magic here. It's like, honestly, the way I make new models is I copy and paste the old ones. Or sorry, make new schemas is I copy and paste the old ones. And just change the field names. So in this class, again, we'll use MongoDB Atlas so that you'll store your data on the cloud, which will make things a lot easier on your server. Then when you want to connect to a database, what really happens is maybe your user is on catbook.com and they connect to the server, and the server just makes a request to MongoDB. And there's nothing magical about that either. It just connects. So that's about it for review. I think this went a little over, so I don't think I have time to answer some more questions about other topics. But this week, we're going to be covering how to do authentication, so logging in, how to do sockets for real-time websites like games or chat apps or something like that. We'll cover how to deploy, so we'll teach you how to put your website up for free on Heroku.com, and we'll cover a few more advanced topics. And that's all.